So welcome everyone. Thanks for joining this lecture, and thank you for your interest in artificial intelligence. This is something that for a long time was not really associated with art in any way. But I believe that with the current progresses, what is really interesting is that we find more and more ways for AI to be incorporated into artistic practice, and this is what I'll be talking about today. So first of all, a few words about me. If you don't know me, I've been focusing on AI art for more than 2 years now, and also working in this NFT world for more than a year now. But my background is really in photography and coding. So I really started with a bachelor's and master's degrees in mathematics. And then I went on to kind of find interest in the new field of computer vision that has just emerged. And as being a passionate photographer for many, many years, this was definitely the field that drew my attention because it was essentially about writing programs that would understand what is in the photograph. So photographs is just a bunch of numbers, and being able to extract some kind of meaning from that really seemed like a magic to me. And this is why I decided to delve deeper into the field, to also do research within the field of computer vision. And I went on to finish my PhD degree on the artificial intelligence at Polish-Japanese Academy of Information Technology, where I worked on multimodal representations. So also learning how to combine image representations with textual representations, and just teaching computers to see, to put it very, very simply. So during this lecture today, I will first talk briefly about what is AI art. I'm sure most of you here have already heard and seen and maybe even tried some AI art yourselves. There has been a lot of media frenzy lately with the Stable Diffusion and DALL-E being open to more and more people. It's getting easier to try out AI art. But it's also very essential to understand that those text-to-image tools, they are not all there is to AI, and AI is just such a broad term with many different tools that you as artists actually can use in a myriad different ways in your own practices. So my main goal with this lecture is also to maybe inspire some of you to try out some of the tools, maybe even if you didn't do anything with technology, but you would be inspired to do some experiments or just play with AI. I would say playfulness is one of the best motivations for trying out this new technology. So let's start actually with what is artificial intelligence and what is it not. And the term itself is a very broad, and it has been redefined throughout decades. Term artificial intelligence has been used already in 50s, 60s, but of course it was a different things back then. And the biggest boom actually that we have seen, it was with the year 2000s when neural networks were introduced. So neural networks on their own, they're not a very new concept. They have also been for quite a long time within the research community. But what happened is that with the computing power, and especially with GPUs that were first used for gaming, but suddenly scientists realized that, well, actually you can do some computations very, very efficiently on those GPUs. Something that would normally take a very long time was now possible to do a lot faster, and also to perform so many more complex computations. So that was one of the reasons why AI kind of took off recently, just like 2 decades ago almost. And also there has been a lot more interest within the field of neural networks and what can be done with them. And the tasks that AI has been kind of designed to answer has been really immense. So there has been applications of AI in medicine, in text, in self-driving. You definitely have heard of many of those. But yeah, it's also very important to realize that AI nowadays is just used as a synonym for neural networks. So all the solutions that are using neural networks are essentially AI in this today's kind of meaning. Of course, it can change, and as the technology goes and changes, it might be a very different thing in a few more decades. And also, what is AI art? One might ask. And when we perform a taxonomy of different genres, quite often we might find AI art classified as a subgenre of generative art. So AI art being art made with computers and also using neural networks. Of course, we don't mean absolute autonomy. There is still no such thing as sentient AI or AI that makes its own decisions and thinks of a project it wants to do and then finds its meaning and tells a story. There's definitely no such thing. It's still a tool, a very complex and a very mysterious tool, a tool that sometimes might feel as a collaborator, and also a lot of actually AI artists sometimes tell they no longer feel AI is a tool for them, but more so of a collaborator. And this is definitely pushing some boundaries of what has been considered generative art so far. So one of the differences of what is the difference between generative art and AI art is that what would normally be considered generative art is something when you have rules that are encoded and the computer behaves according to those rules. When you're using AI and neural networks, what happens is that those rules are actually learned on its own from data. So data is essentially the most important thing for AI. There are, of course, very complex mechanisms, but when we work with custom AI, it usually means not changing the algorithm very much, but mostly it means curating the data to the very personal extent. Of course, those networks, all of them are very different. We have generative networks, we have convolutional networks, we have transformers, diffusion. There is just so many different models. But when we want them to work in a very personal way, and especially when we are applying them to our creative applications, it usually means that the data would be the most important thing that we can use to kind of guide those networks to the extent to what we want to create with them. And it also means that the models will be very much representative of what is in the data. And it will capture the bias that there is in the data, but it also will not capture the data perfectly. And this is where, at least for me, is where magic happens, is when the machine misinterprets some of the information. This is actually something that would allow me to have insights about what is it in my data. So if I have a few hundred of photographs that I've taken during the days, and then I notice machine kind of extract some patterns that were not perfect images that I would take, but something completely else, it might teach me about what is present and also how different machines look differently at the world than just humans. So when we look at things, we are drawn to finding patterns. We are drawn to finding faces and abstract patterns, shapes. We are drawn to giving meaning to things. And the machine is also having its own stereotypes, but they're very different from what we normally see first in the data. So this is where I would argue it's one of the more interesting things when training your own AI models, is to finding those patterns. So actually data is the most important thing, and there's also the saying that AI models are only as good as the training data, and it means that if you put some garbage data into your model, you would normally not get something of a high value, and you would get a representation of what was shown to AI. Now, there is a very important division between different AI methods, and you might have heard some of them. Those are, of course, not all AI methods, but the two categories here are some of the most prominent right now. And of course, AI research is going so fast forward with so many new papers published every day that perhaps, just in a few years, we might see very different names in here. But today, those are probably some of the more popular ones. And on left-hand side, we see methods based on GANs. So it's also a very, very broad name that you might have heard. It is an abbreviation of generative adversarial networks. And those would be the models that you train yourself on some kind of set of content, of visuals that AI is trying to replicate. So this will be a model that tries to replicate some kind of pattern in a collection. On right-hand side are very different AI methods that are based on text and image combined representations. So those normally would be kind of text to image methods where user can input text. Sometimes you can also input images, but this is not to be confused with training on those images. This image that you input as a starting point for stable diffusion, for example, is just a starting point for the network that it goes instead of just noise. It starts with it, but one important thing to realize here is that those text-to-image methods, those on the right-hand side, are the methods where somebody else trained AI and you're not training. You're just navigating a model that has been trained already, and you're of course playing with that, exploring. But this is something where the training actually happens on a very, very large scale and would not be possible to kind of do it at home. So let's start with this right-hand side, which right now I would argue is probably even more popular than the GAN generative-based methods, because it's just so easy to generate AI images with Clip, and which is so actually what is Clip? Clip is this model that learns that words are similar to visuals. For us humans, it's something that seems trivial. If we see a picture of a cat and we see three letters, CAT, it's the same thing, of course. But for AI models, they are usually trained on one or the other. So there are text models and there are image models. And those models learn completely different representations. So they would learn something of what cat is, or what does word cat in English mean. But it is actually not trivial to have a model that would combine those two and realize that this is the same thing. So this is called multimodal in kind of like AI language. Multimodal means that it's combining images with text. And those models that you use text to generate images, they are all built on this foundation that AI understands your language. And this Clip model is right now the most kind of powerful model that has learned so many meanings of words in visual and also understanding images with language. And the reason why it's so powerful is that it has been trained on a massive data set of data. It has been trained on 500,000 pairs of images and text. So this is something that was shown to model. Look, here is an image of pineapple. and here is a word pineapple, and they are the same thing. And there has been a lot of such information that was actually taken from the internet, that was taken from various databases, and was all combined to train this huge model that itself had many parameters. And this is a model that is so big and complex and was training for so long on so many GPUs that this is something that only a few entities actually right now can do. It's something that cannot be trained even if you had 10 GPUs on your own, or if you were a middle-sized company. This is something that has been done by those giants like OpenAI, who have access to such huge resources. Now, the good thing is they share those models as open source, and this is actually also one of the reasons why AI research has been evolving so strongly, is that the open source community is very strong and active, and people are sharing the research, sharing their code, sharing their models, and this allows for very quick iterations because people don't have to rebuild stuff from scratch, but they just go and build on top of what somebody else did. But of course, it also leaves it challenging that with current state-of-the-art models, they're only accessible to some biggest entities. And it really has this risk that what if they decide to stop open sourcing or stop sharing? And even with DALL-E, it's open. For example, it's open to play with the model, but you don't have access to actual weights, and you cannot really see under the hood what's in there. So it poses definitely some risks within the AI research community. One of the first methods that kind of made waves with combining images and text and using text to generate images was VQGAN and CLIP method. And there is a Google Colab notebook link that was used to generate a lot of images. And just a few months ago, it was probably the most state-of-the-art, the most advanced model to create images from text. But of course, going forward today, we have so many more models that it's just, and their quality is also evolving at such a high pace. And one of the ones that was coming next after VQGAN was DALL-E. And as mentioned, there is also another version of DALL-E that has been made public. I think there might be an application process still, but they are onboarding quite a lot of users very, very fast. So it's going to the direction of being more open. Interesting thing about DALL-E is that it actually uses a new way of generating images, which is called a diffusion. And in a very simple way to think about diffusion, it's a process that learns to reconstruct images from absolute blur or noise. So when you think of blurring an image, going to absolute noise, this would be the model that tries to reconstruct it and go backwards, which is, of course, a very difficult task, even an ill-defined task, because when you have absolute noise, you can have so many different inputs that could have been generated from that. Now, with regards to usage of this tool, one thing that is different perhaps from the others is that they have restricted quite strongly the usage of names and living people. You cannot use faces. Those are the kind of their ways to mitigate the bias and try to avoid people generating deep fakes with the tool. But of course, no such tool is fully robust to misusage. So there is still, of course, many ways on how to be cautious about the use of such tools. And as mentioned, there is no training of the model. The optimization happens directly on input image. So if you input an image, it would use it as this noise or blur that has to be kind of reconstructed. What I noticed personally is DALL-E 2 is quite good at rendering photographs. So, and different kinds of photographs, they look often very, very convincing. But of course, there is so many styles that people are discovering and using. Another tool that has been popular quite a lot lately is Midjourney. And Midjourney is on the opposite spectrum of open source when compared to DALL-E. So even though DALL-E has not published their full code anywhere online, but at least they have published, they are very open about the methods that they are using. They have published papers, they have written blog posts that explain how their method is working, and this is something that can be replicated by other scientists. So they are really open about how they created it. Midjourney does not really share what model is being used, as this is fully commercial tool. But seeing how it works, it seems that it is also a kind of diffusion-based model that, of course, also uses clip or something else to connect images with text. What is interesting about Midjourney is from seeing the outputs that get generated, it is quite evident that they used a very curated data set to train that. So DALL-E was trained on like internet, everything on the internet, scraped internet, a lot of Google pages, everything essentially. With Midjourney, it seems that they narrowed down their training to more art-related content. And this is why there is a lot of those very specific to Midjourney textures appearing. They are very good with paintings, imitating. Even some generative art it's really funny to see because neither DALL-E or Stable Diffusion generate some generative art or procedural art looking kind of visuals very well. But Midjourney really creates those very complex patterns quite well and in a very interesting manner. However, as I mentioned, as there is no training of the model, what happens is even though those textures look really good and the details look amazing, but they're quite recognizable. And when you've seen many of
If we ask Echo to turn on, so I'm getting a lot of sounds from the background on top. I don't know if you guys getting that too.
Can somebody maybe mute? I think that there is.
I didn't know that. Oh.
Is it something coming from my side? No.
Someone else, actually. It wasn't you. But it's fine. I muted him.
Okay, maybe try. I also try muting. Okay. Okay, now it's good. Is my screen still there?
Yes.
Okay, perfect. Yeah, so that's also one of the disadvantages of using Midjourney is that those textures, even though very high quality, they are also something that appears in all of the images. Now, Stable Diffusion is one of the tools that right now seems to be gaining most popularity. And one of the reasons is that it's completely open. So as opposed to DALL-E, where there is a waiting list and application process, Midjourney, first, they also opened to only a limited set of users. I don't know how it's right now. Maybe it's more open, but Stable Diffusion just went and completely opened to anyone trying to use their tools. Of course, there is a limited free tier and a paid one, which allows you to run more prompts and more complex queries. What I really like about Stable Diffusion is that they also open up to more parameters. So with Midjourney and DALL-E, you can only input text prompts, but you cannot
really
set and play with different parameters. But with Stable Diffusion,
I don't think we're going to need the full time here. But I know, Margaret, you have a couple things you wanted to check in on, and I had a couple things I wanted to check in on.
Sorry?
Astrid as well. Are you logged in, Astrid?
Daniel has his mic on now, and he's like,
I'm talking about.
Okay. Yeah, I thought there was a question. Well, actually, guys, if you have any questions to the content, to just feel free to ask me if anything's unclear. But yeah, I will also open up in the end to kind of have a discussion.
Okay.
So Stable Diffusion has more parameters to play with, and
Patrick.
And it also uses diffusion technique and denoising autoencoders.
I'm just gonna here's the email.
Okay, so let's go to GANs. So those were the tools that are text to image, and now let's go to a different side of the spectrum. So what happens if you want to train your own model? And this is where you would normally go to GANs and train your own network. And GANs have been here with us for almost a decade as well, and their quality has gotten increasingly better throughout the years. And they're based on quite simple idea that there are two models, and one of the models is generating new stuff and trying to imitate the learning data. The other model, on the other hand side, is trying to realize which images are fake and which images are true. So we have this critic and we also have this generator. And they're working on kind of step-by-step manner where each of them is getting better and better at their own jobs. So in the beginning, the generator does not really do a very good job. It's just creating some blobs, for example. And the critic is quite good at filtering what is real data and what is this generated data. But now, after some time from seeing the information that they get from the critic, they're able to capture what kind of patterns perhaps. Oh, sorry. I think somebody's not muted again. Okay. I think the Discord actually, when you join, it's not muted by default. So yeah. Okay, going back to GANs. So yeah, there is a very cool image by Nadra, which explains it in a very simple way. And I find this image pretty convincing, and it's actually quite illustrative of how it actually works. Yes, so there is a forger, artist, and also critic, policeman. Those are the names typically used to describe those two models that learn at the same time. For artists, one of the best kind of GAN architectures is StyleGAN. As StyleGAN, especially with its latest improvements such as StyleGAN 2 ADA, allows to train on smaller data sets. So in the beginning, when you wanted to train your own GAN, you really had to have several thousands, tens of thousands, ideally hundreds of thousands images to get a meaningful representation. But as the architecture evolved, what happened is that you only need as little as 1,000 or even several hundred photographs to be able to create something meaningful. Now, my favorite GAN is the one in the middle, the StyleGAN 2 ADA, as it's substantially better than the StyleGAN 2 and StyleGAN First, of course. Now, there is also the newest StyleGAN 3, which itself I'm not a very huge fan of, because it's more focused on recreating the spatial information and being able, for example, to rotate images, the generated images. But this information that is learned is quite limited, and I've seen that this effect, what happens is a bit dizziness inducing when you just look at the animations generated with Stalgan-free. But this is a very subjective opinion, of course. You can also train Stalgan-free on smaller data sets of a few hundred images, and perhaps it would work for you better. But yeah, if trying on your own images, I would recommend the second or the third one. Their implementations to kind of see what works for you better. And now, if you're curious about what would look like, what would happen if you trained GAN on your own data, and you were really interested in training your own AI and kind of playing with that, I would suggest starting with a few kind of questions. So actually, even before you start preparing the training data, going through your archives and just collecting those images, I would suggest first starting with a clear goal in mind and also a coherent theme. So this is something that is really important to have in your training data, as the theme has to be something that is quite consistent within the aesthetics, within the shapes, within the patterns. So for example, if we're training a model on humans, it would be better to focus, for example, just on faces than to mix everything. So work with portraits, with humans on the street, with crowds. Those themes are very different to GANs, and they might have trouble in learning all that variety within the data. So the more consistency there is in the training data, the better and the higher quality results you would normally get. It is also very important to be careful during data collection to have it of as high quality as possible. And it also means being careful not to include any accidental artifacts, so not to include watermarks or some weird cropping or some weird padding, because those are essentially the things that, well, we might not even notice them when we are going through our archives and collections, but AI is very quick at capturing those things. So it's also, so for example, it would also be the case that if there is some pixelation in your images, if they were low res, upscaled, but there is some weird artifacts happening, AI would just recreate those artifacts. It would, even though the resolution would be 1000 by 1000, but it would try to mimic this lower resolution. So the more quality you have in your data, the more quality you have in your model outputs. And this is why data curation and data preparation is so important. Also, the question that I get asked quite a lot is, how much data do you use? How much images do you need if you wanted to train a model? What is the kind of minimum image number? And I would say that 100 probably is like the most minimum number of images. But the true answer is that it really depends. And it really depends on the domain, on the distribution of the data itself. So, for example, if you're training on something that is completely different from any other models that you've trained or anybody else trained, then you would probably need even 1,000 or 3,000 images. This is like a perfect number that would give you the most rich representation. But the good thing is that when we start, and if there is any domain that is similar to what we are going to do, we can kind of kickstart the training by using a different model. So this is actually quite natural to understand when you think about that AI has to learn some visual representations. And it is, of course, more difficult for AI that knows nothing about anything to learn everything from your images than it is to train and learn about your images when it already knows about something else. So a simple example would be you want to train on images of flowers, and you have this different model that already knows how to generate leaves or flora or landscapes. So it would take those features that it saw within the first model and kind of reuse them. And this reusing of the model is something that is called fine-tuning, and it happens all the time, and we all use it, and it is very beneficial because it allows to shorten the training time. We don't have to train for so long, and it also allows us to reuse the information that was already learned. So the best practice, it is normally to use one of the pre-trained models and to kind of show your new data to this model that already has learned to create something. And for Stalagan, there's a lot of those pre-trained models. The most popular one is the FFHQ faces model. So it's the model that creates many realistic looking faces. And there are many more. So there are also models, for example, that generate different kinds of animals, cats and dogs. But there are also some more abstract models that were trained off microscopic images. There is a model that was trained on paintings, in particular on faces within paintings. So you can browse and see which domain is the most similar to yours. So the best practice would be, if you're doing anything with faces, then start with the face model or the paintings model. If you're doing something with landscapes, start from a model that already knows landscapes. But also, if you don't see anything similar, I don't know, it's like astronomy and there's no similar model, I would suggest nonetheless not starting with absolute noise, but yeah, start even with faces. And then it will then forget some of the face features and learn what are the astronomical images, etc. And another thing to realize when preparing this training data is that it is a very different thing what we consider the same theme and the same concept and what neural networks consider. So, for example, just a very simple example. This is a concept of Africa, and this is the Google Images search results for Africa. And we see pictures of people, of maps, of landscapes, and for us, it's all very coherent. But of course, if GAN was trained on such a collection of images, it would just show a complete garbage, and it would try mixing those concepts. So here are some examples of the training data that I used for some of my projects. This one was made in collaboration with Janie Fitzgerald, photographer, who did microscopic shots. And what was very interesting was the use of the solarizing filters. So we kind of got this aesthetic that was very consistent within the training data. And even though we used different close-ups, further-up shots, but the use of the filters allowed for kind of GAN to quickly learn some of the patterns in the data. And another collaboration project that was focused on Hong Kong nuance. Here you can also see that the theme, all of the images are shot during the night or at least after dusk. There is a use of strong color within all of them. The nuance itself, they had those letters, the Chinese language letters, and some close-ups, mostly close-ups. So there is a very, they're kind of bounded distribution that we used for training. And now, after you train the model, one thing, this might look like a very complicated picture because it has some maths in it. So sorry for that. But I found it I found it actually a nice visualization of what is this thing that AI learns. And it's important to realize that AI does not learn to generate 100 images or 1,000 images that are similar to your collection of data. What it does, it learns this continuous multidimensional space where each point of the space, so it's not 3 dimensions, it's even more, and each point corresponds to some numbers. And for each of those numbers, there's an image that can be generated. And what happens is that we can smoothly go from one point to the other and to have an image generated for each of those points. So as in the example of this smiling man, we can actually generate videos by essentially going through the space and creating an image for each of the points on the way. 60 frames per second, we convert it to video. And this is actually how I create my animations. There is also a very common misconception that I get asked about is, how do you animate your photographs? And the thing is that, well, those are not photographs, those are generative images. And then they are not really animated, but my animation shows the movement within the learned generative space. So there is like naturally already a movement within it that I just capture and show and find the most interesting paths, how you can move through this space. So here's another illustration and kind of shows how for different directions you can achieve different changes from the same starting point. So now I would like to also briefly mention that there are some other AI methods that are perhaps also useful to consider for your own practices. If you want to try something else, then text to image. If you want to try something else, then training GANs on your own images. One of the methods that has been a bit forgotten, but I would argue it still has a lot of possible applications creatively, is, for example, style transfer, where you can transfer different kinds of styles on different kinds of content. And it's especially interesting to explore that, of course, with your own work and to find different avenues for that. There are some limitations of style transfer, of course. But once used in a new setting, there are still some very cool things that you can achieve with that. And it works by essentially, you just need 2 images, one image with content, one image with style to get one on the other. Another field that is very fascinating is, of course, generative text. And with GPT-3, that is the most powerful right now language model. It is becoming very easy to generate a variety of different texts, also in the different styles. There is a very cool tool, Pseudowrite, but you can also use GPT-3 directly. And there's also a lot of kind of cool things that you can do with that. So, for example, what I used in one of my projects is I used the Pseudowrite to generate the description for my piece that was actually starting from my own words. So I inputted a few sentences about the project and allowed AI to work on that and create a longer text that I then fed back to the visual inputs and fed back into the artworks in a fragmented manner. Also, there is a very cool and I would argue underexplored field of generative sound. And it can be used in a variety of ways as well. You can generate sound with AI, you can generate sound in a particular style. It also works very well, for example, if you want to add some sounds to your work, if you're working with the animation medium, for example, and you don't want to collaborate with sound designers, but you feel that the sound aspect would add a new dimension to your work, you can just use AI tools to create some some royalty-free music, essentially, that you can tweak, and even without any music knowledge, to kind of play and see what works good. So this is also a very, very cool way to explore. That also works even without training. And what's more interesting, there are also audiovisual AI methods that allow to create audio reactive visuals. And this works by taking as an input an audio track and a trained GAN model, and then it would move the visuals with the direction of sound. So it would make them audio reactive. I don't know if it will play if I just do that. So you can see here, I don't know if you can see that or no, but I will share the presentation later. So you can check out an example made with a Lucid Sonic Dreams library, which allows you to do that, to input an audio track and trained GAN. And what you get is those audio reactive visuals, which are also a very cool thing to play with, especially if you're thinking about installations, working with sound designers. It allows for very interesting kind of immersive ways on how to interact with your art. Okay. And another thing worth mentioning, not a method perhaps to explore in creative ways, but of course, why not? You can also try that. But it's an useful tool when working with those GANs and AI tools and all the others, is the super resolution for post-processing of your works, to kind of preparing the final piece. And it is essentially important because, well, we are still quite limited with AI tools. What I haven't mentioned is that most of those methods would provide images that are up to 1000 by 1000 resolution. And of course, it's not super high quality. So a lot of artists would normally use a super resolution tool to kind of create those details, to upscale the image so that it could be printed in high quality, showcased in large formats. And this is one of the limitations that perhaps might be overcome in a few years, as it will be possible with the more compute power or just different kinds of networks to train outputs. But right now, the problem is that if you wanted to create images that are 4K, 8K, it would need a lot of parameters and a lot of compute power that is not as accessible. Of course, some of the tools, so for example, text-to-image tools, they can be created slice by slice manner. So you can stitch together many, many images and have something that is super high res. But nonetheless, using some of those tools is actually pretty beneficial. Tools like SRGAN, Swinair, Gigapixel, Topaz. So Gigapixel and Topaz actually work on videos, which is really cool, because you can enhance frame by frame your videos. But they work on all kinds of outputs. So yeah, even not only generative. So they of course work also on photographs, on digital art, and their power is quite substantial. So yeah, something very useful in every artist's toolbox for different applications. So lastly, a few links if you wanted to try it at home. Artbreeder is actually an older tool, but a lot of artists were having fun with that. There is Runway ML, which is like a good starting point if you wanted to train your own AI model, if you wanted to train your own GAN, but you don't have coding skills or you're not ready to learn them. Then I would say Runway ML is a very good starting point to kind of train your first model and see what happens. And if you like the results, then you can go further and learn more about it and do something more advanced. So Runway ML, it will not provide you the best possible results with your model, but it would provide you a good starting point. So you can kind of see the idea of what could happen if you trained GAN on it. But yeah, it's very accessible, so definitely no coding skills required here. And there's also Playform, but this one is more for style transfer kind of tools and playing with your images. There is also an interesting tool, Deep Dream Generator, where you can play with the method I actually haven't mentioned, Deep Dream, which is like creating artifacts on your work and allowing AI to go forward and imagine more details within your piece. And if Runaway ML is something that you like to train your first model and you wanted to learn more and you actually want to dig deeper, then for those, what you have to learn is, first of all, some command line basic knowledge to learn GitHub, learn basics of Python. That would be like a to-do list for those who want to kickstart their deeper understanding of AI art, some of the resources. And also a few points actually for creating AI art to remember is, first of all, we're using a lot of open source. So it is a good practice or a good etiquette to credit the model, especially if you're using something open source. So if you're using DALL-E or if you're using a model that you found somewhere, it is a good practice to mention that. Also mention the data set if you're not training on your own, on somebody else's, of course. Be mindful. This is still a gray territory. Can you train on somebody else's data? The thing is that when you train a model on visual inputs, not a single pixel will be the same. So a lot of people argue that it's okay. But of course, the problem is that it is mimicking the style. And the style is something that, well, it's a gray territory because you cannot license style, as far as I know. So yeah, this is something that you could perhaps do it, but it's better not to. At least it's a better practice to, of course, credit or get a permission if you're going to use somebody else's images or photographs or some archives. And another thing is also, if you're working with those models, it's so easy to generate millions of images. They're just a push of button away. But similarly to photography, it doesn't mean you have to. It just means you have to maybe think longer before doing that. Think about what's your goal, what's your motivation, and try to explore in a particular direction. Finally, also be aware of the potential biases. So a lot of those tools are trying to mitigate the bias. So I've noticed, for example, with DALL-E that when you research now terms such as scientist or coder, you get people who are different genders, different races, but it was kind of it was something that was hand curated by the authors of DALL-E, because the training data itself was very biased, was quite racist, and also had many of the stereotypes that are in the internet. As I mentioned, whatever the data gets into AI models is what gets learned. So of course, in the internet, we have a lot of the negativity and a lot of those cultural stereotypes that are there that were, of course, mitigated with AI. And not all of them are so easy to capture. So this is also something to be mindful, especially when working with models that have been trained by somebody else, to realize what kind of biases might be there. It can also be a very interesting project to try to find those biases, to try to find to use queries to see what is the internet's representation of a writer, of an Englishman, of an American. It is actually a very cool tool to explore that. One of my favorite things to do with those text-to-image tools is just input different nationalities and see how they are represented with the internet. This is essentially what is done with DALL-E or Midjourney or Stable Diffusion. And finally, consider carbon footprint. Model training, of course, might take a lot of energy. So there are some good practices such as fine-tuning, so not starting training model from scratch, training for only as long as you need when you like the outputs to stop training of the model. They are, of course, not as energy consuming as blockchain, which is, some blockchains. But I mean, as many other things, it does consume a lot of energy. And here also some links for those interested. There are a few very good courses that I recommend if you want to learn more about AI art. Especially the first one by Derek Schultz. It's for those who want to train their own GAN models. But also there's a great course from MIT about deep learning for art aesthetics and creativity. And there are a few reading materials about the details on how does Clip or DALL-E work. And a few other tools for just working with AI and not really thinking about how it works. Yeah, so this is all from my side. So I think I'll stop sharing right now. And I would be happy to hear any questions you have, anything that you would maybe want to learn more about. I also see that there are some comments in the chat, so I will see. Okay, the first question was, how long does it take to train on 1,000 images, let's say, one GPU? That's a very good question, very down to earth. And the answer is that, of course, it depends, unfortunately, because the definition of a trained model is something that is absolutely up to artists to decide. So, for example, let's say that I'm reusing a model. I'm reusing a model that knows how to generate faces. And now I want to train on one GPU and 1,000 images of cars. And the question is, what do I want to learn? If I want to learn something super bizarre that is in between cars and humans, I would just need 2 hours. After 2 hours, I would get very bizarre images that are half cars, half faces. I haven't seen that, but sounds like a cool experiment to do. But if I want to create something that looks more like cars, I would have to train longer. And the longer I train, the closer it gets to the car data set that I have. But here again, the question is what I want to achieve. So for me personally, what I like to have is a bit of ambiguity in the data, because I aim to represent very universal kind of feelings and concepts. So I don't really like to train it so long so that the images that my GANs generate are super realistic and people have trouble saying that whether it's true image or not. And it's also the case that, well, why would I need AI to do that? I don't want to have a perfect image, a photograph of mine. I can just take that photograph. I want something else. So yeah, it really depends on what you want to achieve. And yeah, if you want to achieve like a perfect representation, then on one GPU, it would take a couple days. But also it also depends how good your training data was. Because if it wasn't good enough, then it might also happen that you can train for months and still not get what you want. So yeah, it's quite a complicated answer. I don't know if it helps. Touch sound art. Okay, there has been another comment about Cypher Media. They have generative audio beats. That's very cool to know. I also see that Franco has tried Sonic Lucid Dreams. That's amazing. Yes, this is a great tool. I really love it. And yeah, the creator of it, Michael, is also a great artist. So definitely cool to see that. Some useful links. Very cool to see that. Okay, there is another question. Do you see a shift in artist usage moving towards having AI in a pipeline versus releasing more raw output? Yes, that is also a good question. I would say that as the tools get so accessible, it is no longer interesting to just have the kind of raw output, but it also depends on what your pipeline is. You might have a very complicated AI model that mixes some of the models, that tries to learn some complicated data set, and then you would have raw output that is a perfect representation of what you want to have. So I would say that there is definitely a shift from just imitating some forms of art, which has been very interesting for some time, imitating paintings, photography. But of course, as the popularity grows, people will get bored of that, and people are already getting bored of just pretty images generated with AI. There has to be something more interesting for it to capture attention. Okay, so Bruta has a question about video clip models. I have not experimented with them already. I have seen other people do that. There are still many limitations. There is a lot of workarounds on that, on how to have video with clip. But yeah, it seems like a very interesting kind of research direction. I also see a lot of research papers published with this goal in mind to kind of have text to video methods, and it's of course something that can be done, but it also might mean retraining on huge corpus of data that have those relationships between video and text. Of course, we have YouTube and other services that might be helpful with getting this kind of data, but the video itself is a bit more complex usually, and than just a single image to have it described with words. So it is, of course, a lot more challenging problem that scientists, researchers are still tackling. Okay, so there's also another question from Touch Sound Art about where can we get these pre-trained models. Yes, so there's a link. Actually, I will just share the link here to my presentation so that you can see all the links. And the thing is that, first of all, it depends on what kind of framework you're using. So if you're using PyTorch, then you need to look for any PyTorch model. If you're using TensorFlow, you have to look for this particular format of models. But you can just use any model you find on the internet, somebody that has published somewhere. I posted a link to NVIDIA repository, and they have some nice pre-trained models there. If you use Runway, there is also embedded a lot of different models that you can use as starting points. But if you're using Colab Notebook, you can just export any model you found anywhere on the internet and use it as a starting point. So it's very compatible. And even if you find a model in different frameworks, so for example, you find a model in PyTorch, but your Google Colab is in TensorFlow, what is cool, there are scripts to convert those. So for example, in the materials from Derek Schultz, there are some scripts for converting models from one type to the other. That was also a very useful thing to do. Okay, the question from Victor: can you teach something new to a stable diffusion model running locally? So no. Essentially, you cannot teach anything to stable diffusion. Stable diffusion has been trained by the team from Stability AI, and now what we are doing is just inference. So when we are running this model, we take model weights, there are some set numbers, and we are not changing them. They are set in stone. The diffusion model has seen its share of internet, it has seen its share of images and words, and it will not learn anything new. What you do is you can choose your different starting points. So you would choose something that the model has not seen. And it's, of course, very interesting to give it some starting points that are completely different from the data distribution that it has been trained on. But yeah, I would say this is one of the drawbacks also when working with text-to-image models, is that they have been trained. They already know everything, and we are just exploring those forests of knowledge. But it's just discovering. So working with text to image is essentially discovery. It's not truly creating something from scratch. Well, unless you use some different ways of kind of, maybe a weird starting image and only a few steps of diffusion, then of course you would get something that diffusion has not really seen or created.
Can I ask something regarding the use of DALL-E?
Sorry, could you repeat that?
Can I make a question regarding the use of DALL-E? Yeah, so I've been using DALL-E lately, just trying things around. And what I've noticed that sometimes when I do prompt edits on an input image, sometimes I will run the processing, but then DALL-E wouldn't do anything. And the prompt lines are super simple stuff. It's not like I'm writing a huge text, I'm just saying, okay, I want this on this part of the image, right? I'm just erasing a little bit and then I'm writing the prompt. And I had it a few times that I'm writing the prompt and running it, and then it does nothing. The output images are 3 images of the same pretty much in the input, So I'm wondering if that's something related with the inputs, or is it that something related with the model training? That's pretty much my question.
Yeah, that's a good question. This is something I also noticed, and that's so. First of all, there's one thing: how DALL-E works when you want to edit your image. What it does is when it gets your image, it tries to find the most similar image to your image within its space. So as it has been trained, it is able to create a lot of different things, cats and dogs and people. And then it sees your image and it thinks, okay, so what do I have that is most similar to this thing? And so here's the first problem. It might not find anything similar to your image, and then it would really struggle to create anything. The other thing is that when you give your own image to it, you also have to describe it in a way that corresponds to your image, and then add this additional text, which is also not something that always works, because sometimes, this text representation does not really correspond to this image. It might be something that is absolutely out of data distribution for it, or it might be, I don't know, the case that you're feeding some black and white image and you want something there that in its data it never existed on black and white. I'm just thinking out loud, but those are usually the limitations that DALL-E is having problem recreating your image within its space. So from what I noticed, a good first step would be trying to recreate something as similar with DALL-E, and then work from this text prompt that works closely.
I guess probably a better option will be stable diffusion, from what I heard. But more accurate, I guess, or maybe a wider database, more artistic, so on.
So with stable diffusion, why it would be better for your own images is that you can control more parameters. And it's also a very nice thing that is lacking in DALL-E, that with stable diffusion you can control the strength, the influence of your image versus the text query. So we can say, I want 95% of my image, but just 5% on this text query, or vice versa. And you cannot really kind of control those parameters. with Delhi. So yeah, there's definitely a lot more flexibility, and yeah, this is something also that does not work at all in Midjourney. So if you input your own image to Midjourney and try to change it, it usually changes everything a lot. It might correspond to text query, but not correspond to your image. So yeah.
Thank you.
Okay, so I also have a question from Lila about going the next step from Runway ML. Yes, so the next step would definitely be trying to train your own model in Google Colab. So in this presentation, there was a link to Google Colab for training your own GAN. And I would recommend, actually, what I would recommend is doing the Derek Schultz course that I linked, because there are some really nice resources, some really nice Colab notebooks. And the Colab notebooks can be intimidating at first because, well, it's a bunch of code. And if you have never seen or written code, it can look weird and scary. But those Colab notebooks are designed in such a way that normally you just have to tweak a few parameters and can just, click through it and don't really have to dig deeper to understanding what's in it. So yeah, I would recommend this course, Lila, definitely. And also another question, I see that with regards to avoiding during data collection when training GAN is low pixelation images. Okay, and what guideline is that? So when training GANs, we are training on 1024 by 1024 resolution. So ideally is to have images at this resolution. Of course, anything bigger, downsampled to this still would work. But anything that is lower than 1000 by 1000 might mean generating some weird artifacts. So yeah, this is just quite a simple rule. Also, what you can do if you have images that are lower resolution, and something that I've seen a lot of artists do, is that you would take your training data and then feed it through some upscaling tools, super resolution tools to get higher resolution, to get rid of those artifacts, to get more details, and only then feed that to GANs. So this is also another thing that you can do if you have something of a lower resolution. Okay, thank you. So thank you so much for so many questions on the chat. Is there any other questions that maybe you have? Feel free to speak, or any comments that you have, or your experiences with AI, maybe, if you also wanted to share.
Did you maybe recommend us some sound generative tools for AI? Like anyone in particular that you think it's nice? I know you named one already that I tried before, but maybe if you have others.
Yeah, so actually for generative sound, I only used the Beethoven. It's very limited also, but for somebody who's not musical at all, as I am, it was a very cool experiment. If you're into sound design, I would definitely kind of recommend trying to train on your own sounds. And there are tools like that too, but I would have to look for a link, or just try Googling the Colab notebooks for training your own networks. Oh yeah, there is some link from Hidden Forces.
Perfect.
Okay, everyone. Anyone else have any more questions? There's one question in the chat from Touch Sound Art. Where do you get your links and resources?
Yes, so I shared here in this chat. Does this chat stay after the class, or should I maybe share?
Yes, it does.
Okay, so I'll just share it once again so it's... So here's a link to the presentation, and when you go through the slides, there are hyperlinks inside it.
Awesome, thanks so much.
Thank you so much. Yeah, thank you. Thank you all so much for being such an amazing crowd, and thank you for beautiful comments. A lot of friendly faces here. Actually, yeah, it's one of the nicest things that so many friends on this chat, on this talented cohort. So yeah, congrats to y'all. Thank you.
Thanks so much, Ivona, for your lovely class. I know that everyone has millions of questions and interest to continue their journeys with it, and I just want to wish you all the best, and thank you so much for your marvelous lecture.
Thank you so much. Yeah, just one last comment. If anyone had any kind of like maybe questions related to their own practices, I'm also available for some one-on-ones. So yeah, if you haven't already, you can email me, and yeah, we can discuss more on your own example.